Well, hello everyone. Today we are going to start with a new module, Module 12, IPv6 addressing. Now, we already had some idea or some background about IPv6. Um, Today we're going to go into details about IPv6. And I do have some good news before we start. IPv6 is a lot easier compared to IPv4, so this should not be a really complicated topic to cover. Now, the first thing we're going to talk about, I'm going to go through the PowerPoint, and then every time we have to do some calculation, I'm going to open a Word document to show you the calculation, and by the end of the chapter, I'm going to go to Packet Tracer to demonstrate some of the concepts. Right after we're done with this chapter, the other chapter, which is Module 13 or Chapter 13, it's a pretty short chapter that I don't even think I need to create a video about it. So you can go ahead and read the PowerPoint, read the Net Academy, and you should be fine. What I'm going to do after I'm done with those three modules, which is modules 11, 12, and 13, I'm going to create a scenario. And in this scenario, I'm going to create networks, and I'm going to configure routers, switches, computers, and I'm going to demonstrate everything we learned in the first 13 chapters. Now, whatever I'm going to do in that video is basically going to be your final skill exam. So this will be really, really helpful if you want to get ready for the skill exam to understand what I'm going to do in that packet tracer file. Let me just show you that section. It's not this one. It's basically this one. I'm going to have two computers, two switches, one router, and I'm going to configure everything about those devices. For this chapter, I'm just going to use this network here. It's a simple two computers connected to a router directly. So let's go back to the PowerPoint. So the first thing we are going to talk about is the issues that we have with IPv4. Well, we have a lot of issues, and we talked about them before. The biggest issue that we have with IPv4 is the limitations of the available number of IPv4 addresses available. And with these days, we have something called the Internet of Things, IoT. Internet of Things basically means your refrigerator is going to be connected to the internet, your car is connected to the internet, your watch is connected to the internet. Basically, everything is going to be connected to the internet. And that basically means more and more devices are going to be connected to the internet. And we know that IPv4 by itself has a very limited number of IP addresses available. So we came up with IPv6, and the main difference between them with IPv4, we have 32 bits, that's the size of the address, and with IPv6, that's 128 bits, that's the size of the address. Now, as you can see here, since the size is a lot bigger in IPv6, that basically means we can have a lot more devices. And because of the limitations of IPv4, we had to create what we call a private private IP addresses and public IP addresses. Now, with IPv6, we don't need to have all of that. Now, as I said before, it looks like IP address version 6 is going to solve all the problems that we have. So why don't we just switch and use IPv6? Well, as I said before, the reason is it's really, really expensive to force everybody to ditch and just throw all their IPv4 devices and replace them with the new ones that support IPv6. That process is expensive, and because it's very expensive, we're just going to hope that with time, all those IPv4 devices are going to be replaced with an IPv6. Hopefully, in the near future, we don't have to worry about IPv4 anymore, and we're just going to be using IPv6 for the rest of our lives. So, how do we solve the problem of having IPv4 and IPv6 coexisting together? Well, there are three suggestions and three algorithms or three protocols are used. And this is very important to understand them because I believe you'll be asked about them. So we have what we call a dual stack, tunneling, and translation. Now, dual stack basically means every time your device is going to produce and create a frame, basically create an IPv4 and IPv6 together and send them together at the same time. So you're sending IPv4, IPv6 at the same time to your destination. If it happened that you got to a device that doesn't support IPv6, then at least you have the IPv4 to continue with the job. So basically means you're sending IPv4, IPv6 frames or packets together at the same time, and you move from one device to the other, and your device basically going to be able to process both of them until you get to a point where, oh, I got to a router and this router doesn't support IPv6. Well, ditch IPv6 and just use IPv4 to get to the destination. This is not a really practical solution for the problem because, again, you're sending your data 2 times, one of them using IPv4, IPv6, and then you're asking all the devices to process both of them, and that's basically consuming the resources. So, but it's a solution, but it's not really a practical one. Now, we do have another solution, which is translation. Now, what are you going to do, basically? You're going to send your IPv6 frames into the internet, and the moment you get to a device that supports IPv6 and the other device that's connected to it that doesn't support IPv6 just support IPv4, then your device is basically, I'm talking about routers here, you're moving from one router to the other. Now, the router basically will have to convert that IPv6 to IPv4 using a protocol network address translation 64. It's very similar to the one that we talked about before when you convert your private IP address to a public IP address. This time you're going to convert your IPv6 to IPv4. So the device with the that only support IPv4 will be able to process that frame. Now the last one is tunneling. Tunneling basically means that you will have an IPv6, but you're going to encapsulate the IPv6 using IPv4 protocols. So just think about it like you have a frame, and this frame, let's say, it's IPv6, so all the IP addresses are IPv6, and the header is IPv6 and everything, and then at the top of that you put IPv4. Now you send your frame through the internet and through the networks, and then every single device will receive it as IPv4. And now, if your device only supports IPv4, then it's going to just treat it as an IPv4. But if your device supports IPv6, basically that IPv4 encapsulation information is going to be thrown away, and then you're going to get into the IPv6 and use it instead of IPv4. So you have those 3 protocols to solve the problem of the coexisting of IPv4 and IPv6 at the same time. Now we're going to talk about IPv6. Now, let's go ahead and talk about information about IPv6. First of all, IPv6 is 128-bit. And we said we are going to use hexadecimal numbering system to present IPv6, not decimal, not binary, hexadecimal numbering system. And the IP address is going to basically organized like, as you can see here, you will have a hexadecimal numbering system, or digits, 4 of them, separated with columns. So you're going to have 4 here, 4 here, 4 here, and 4 here. So you got 16 of those segments. Each one of them has 4 hexadecimal digits. That's very important to understand. Now here we have some examples. Well, here we go. So this is an example of IPv6, and here's another example of IPv6. And as you can see here, every 4 digits are hexadecimal numbering systems. This is hexadecimal, 4-digit, hexadecimal, 4-digit, hexadecimal, 4 digits. So how many of those I will have, basically, as you can see here, I got 16 here, and I have 16 here, so all over 32 hexadecimal numbering system. Now each one of those hexadecimal numbering system by itself is 4 bits. So if you multiply the 32 by the 4 bits, you will get the 120 bits. Now, one of the biggest difficulties dealing with IPv6 is the length of it, as you can see here. Now, again, remember, this is hexadecimal. It's not binary or hexadecimal. So this is basically a very, very short presentation if I want to compare it with the binary presentation. But still, it's very, very long. So we said we have some rules that we can use to reduce the size of this IP address. And I'm going to copy this. Copy it. Let's hope I could copy it. Let me go here and put it here. Nope, it didn't work. Let's try again. Nope, that's not it. Let's go back. Try to copy it again. Now, here we go. Copy that. And let's go to the Word document. So, let me just increase the font size here. Download. Okay. Download. Oops, don't go there. No, never show me again. Let's increase this font size so you guys can see it clear. So the idea here, how do I reduce the size of this? Well, there are two steps that we can follow. Step number one, you need to scan your hexadecimal numbering system or the IPv6 from left to right. And now every time you see a 0 for every one of those 4-digit segments at the beginning of the number, you can take that out. So what I'm going to do, I'm going to look at this IPv6 here, and you can see here that I got a 0 here that I can take away, and I have a 0 here that I can take away. Let's just make it a little bit different. I'll put 2 here, and I'll put 0 here. So I can take this 0 away, and I can take those 3 zeros away. Now, can I take those 2 zeros here? No, you can't. It's in the middle. You have to keep them there. But I'm saying if you have any 0 or zeros from the left, you take them out and delete them. So let me just copy this and show you what would be the results of the first phase. So I'll take this 0 away, and I'll take those 3 zeros away. Now, when I look here and I just see 2, I can understand, since I need to have 4 digits here, so the missing digits are basically zeros. Since I have 3 here and there is 1 digit missing, then I know the 0 that should be to the left here. Not the right, the left. That will be number 1. Number 2, every time you see multiple zeros, or sorry, 4 zeros, specifically 4 zeros, you can replace them with a single 0. So I can come here and take this out and put a single 0. I can do the same thing here, single 0. Take those away, single 0, and another single 0. And that will be the end of the first phase. And I can see, as you can see here, the length of this IP address has been limited, and it's very, very short right now. Okay, what do I do after that? Well, I know for sure that I need to have 1, 2, 3, 4, 5, 6, 7, 8. 8 segments separated with those columns. Now, every time you see a sequence of zeros separated with colons, I can replace them with a double colon. And that's basically will be applied here. So if I copy this and I go down, I can take those 3 zeros and replace them with a double colon. Here it is. Now I am done. As you can see here, it's a lot shorter compared to this one. Now, if I ask you to reverse it, give me back the original IP address, IPv6 address. Well, what I'm going to do, basically, let me copy this. I'll start the process of reversing it. Oops, I don't like that. Let me just type it. 2001 DP8 01111 : 2. So the first thing I should know by looking at it, I know that I should have 8 of those spaces. Now I do have 1 here, I do have 2 here, I have 3 here, I have 4 here, and I have 1 here. So that's 5. That basically means I'm missing 3. So I can replace those with those 3. Now if I calculate 1, 2, 3, 4, 5, 6, 7, 8. So that's the first step that I'm done. Now all I have to do, add back my zeros. So I know that I got 1 digit here, so I'm missing 3. And then I have 1 digit here, so I'm missing 3 again. Missing 3 again. Missing 3 again. And here we're missing 3 again. And here we're missing 1. And now you can see here, I got it back. This is something everybody needs to master. You need to know how to convert your IP address version 6 to a short form, and how, if you have a short form, how do you convert it back to be a long form. As you can see here, I didn't even use binary to do that, which is basically a good thing. Okay, so let's go back to the PowerPoint. Here, those are just examples to show you how the rules that you have to follow. We have rule 1, rule 2, and I just explained that. Now, let's move on into something new. Types of IP addresses. Well, you have basically 3 main types. We have a unicast, multicast, and anycast. Unicast, just like IPv4. You have 2 devices. They will have unique IP addresses they're going to communicate. There will be a communication between them using those unique IPv6 addresses. Now, multicast, basically a group of computers will be connected together using a multicast IP address, just like what we had in IPv4. Anycast, basically, this is in IPv6, we don't have a broadcast. Instead, we have what we call an anycast. And anycast works in a little bit different way comparing to IPv6. We remember with IPv4, we have the broadcast message, broadcast IP address. Well, here we don't have broadcast IP addresses, but we have anycast IP addresses. And again, anycast IP addresses are not. We're going to talk about them later at the end of this chapter, so you don't have to worry about that. But again, remember, there is no broadcast IP version 6. Okay, now this is where it gets a little bit technical. Where is it? Here it is. Let's go back and look at IP addresses, and let's look at the one that I just had here. This is an IP address. Well, usually IP addresses are defined into 2 main sections. Any IP addresses. There is what we call the prefix and then what we call the interface ID. Now, think about this. The prefix is basically the network portion in IPv4. And the interface ID is the host portion in IPv4. You remember in IPv4 we said we're going to divide the network IP address into 2 sections, the network portion and the host portion. Here we basically do the same. We have network portion and we have host portion, but we don't call them that. We call them the prefix and we call them the interface ID. Now, the good news is it's always half. So half is going to be for the prefix and the other half is going to be for the interface ID. So this here, the green one, is the prefix, and this part here, the yellow one, is the interface ID. Now, how do I know? How do I decide that? Well, basically, every single IP address version 6 is always followed by a backslash and a number, and that number here is 64. Now, as I said, the good news is we are always just going to use 64 all the time. That's going to be the prefix. Now, can I use something else? Yes, you can, but again, it's not recommended. So, this 64 basically telling me that I have 64 bits here for the prefix, and I have another 64 for the interface ID. Now, I want you to put this under consideration, and you have to understand what do we mean by that. This is going to be used later a lot, so just pay attention to this part. Now we talked about the types of IP addresses. Now we're going to keep going into a different categories of IP addresses. Now, every single IP address or every single device, or every single port that you're going to assign an IP address version 6 to it, basically will have 2 types of IP addresses, version 6. The first one is called the Global Unicast Address, GUA, and the other one is called Link Local Address, LLA. Now, what are those? Number one, let's just put it this way. Whenever you have a device, and let's say you're just going with IPv6, you're not even considering IPv4, your device needs to have those 2 IP addresses, Link Local and a Global Unicast. Now, as long as your device is trying to get connected to a device within the same network, you'll be using Link Local. The moment your device is going to try to get connected to a device that is remotely distanced from your device, like a device in a different network, then you go Global Unicast Address. So every single device will have 2 of them. If I'm trying to get connected to my neighbor device, I'm going to use the Link Local Address. If I'm trying to get connected to a device that's in a different city, in a different country, then I'm going to use the Global Unicast IP address. So this is very important to understand. Those two type addresses. One of them for internal use and the other one for the global use. Now, the good news. A link local address usually is going to be generated by the operating system. You don't even have to do anything about that. But if you choose not to use the operating system IP address, then feel free to create it your own. I'm going to show you how to do that later. So, global unicast, remember that this is basically the device the address that your device is going to have whenever you're trying to get connected to the internet. A link local is basically whenever your device is trying to get connected to your, let's say, brother's computer in the other room from your house. Okay, now, we need to have some information about those two IP addresses. Number one, how do I know which one of them is global and which one of them is link local? Well, usually global IP addresses starts with 2 or 3. And this is just to show you that let me just go back here. As you can see here, this is my first segment of this IPv6. And this 2 here by itself, it's 4 digits, 0, 0, 0, 0. It's not 0, 0, 0, 0, because it's 2, so this basically is 1. Now this could be 1, this is always going to be 1, but this one could be 1 or could be 0. So if it's 0, that basically means I'll start with 2, and if it's 1, I will have 3. But usually we go with 2. So that's the first thing you should know whenever you start an IPv6 global unicast, is the first digits is always 2 or 3. Okay, now you may ask me, what is the subnet IP address? I'm going to talk about that later, but I'm not going to mention it right now. But all you have to know is basically your IP address version 6 is going to start with 2. And then after that, 2 what? It doesn't matter. We usually use 2000. Now, how about, we're still talking about that, okay. The IP address, the global unicast address, is divided, as you can see here, into 3 segments. Now, what? You just said there are 2, like I did here. Well, what does that mean? Why is it 3 this time? Well, let's just talk about this here. I'm going to copy this, and I'm going to put it down here. Now, in IPv4, we said usually you will be giving an IP address, and then we can ask you to divide this IP address into smaller IP addresses. And this is basically what we're trying to do here. If you have an IP address that covers a lot of devices, I can divide this IP address into multiple segments. And the idea here is very simple. You're going to divide your IP address into a global routing prefix, subnet IP, and interface ID. Now, the thing that you should understand, which is very, very simple and very easy, we are going to take part of this number here and dedicate it to be divided into different networks. So what does that mean? Let's just imagine this is my IP address, IPv6 address. So this is my IPv6 address. And let me change it a little bit. I'm going to put zeros here, 0, 0, 0, 0. And I'm going to put 0 here just for it to be an IP address for a network, not a device. So this basically is telling me that the first 16 hexadecimal digit or 64 bits are for the prefix, and this section here is for the interface. Now what I can do, I can decide that I'm going to use this bit here, this 0 bit, to divide my network into multiple networks. So if I took this 0, if I want to use this 0 to divide my this IP address into multiple networks, basically I can have as much as 15 different IP addresses. Network IP addresses, to be specific. And what are those network IP addresses? Remember, this is the big network, IPv6. And now if I want to divide this big network IPv6 into smaller ones, all I have to do, look at this, I'm going to copy this. And I'm going to come here and change this 0 to be 1. And remember, let me just highlight it. I'm using 1 hexadecimal digit, which basically means, let me choose a color that's red. So I'm using one hexadecimal digit, and this hexadecimal digit basically means I have 4 bits. Remember that. And now I can have it to be 1, I can have it to be 2, I can have it to be 3, I can have it all the way to F. So basically 0 is going to be reserved for the big network, but from 1 all the way to F, that basically means I can have that much of networks. Now let me just put those dots. So the whole point here, what I'm trying to say is, if you have if you have an IPv6 IP address, you can divide that into multiple subnets. And this subnet, basically, I'm using only 1 digit, which is basically 4 bits, and I can have 15 different networks. What if I'm using 2 here? Well, that'll give me more options, but again, usually we just stick with 1. So let's just imagine if I give you a network IP address, and I'm going to use this one here again. And now, since I'm using 1 digit here, so this is not 64 anymore, because this portion here represents the prefix, and this segment here represents the subnet. So this is basically going to be 60 instead of 64, because 4 bits has been reserved for the network. Usually that could be the case, or I could actually be using part of this. So I'll just go put it back. Instead of using this bit, I can be using this one of those bits here. Anyway, again, every single question will give you a different scenario, but you just have to understand that one of those bits basically, or 2 or multiple of them, are going to be used for subnetting. What I can do, if I want to have this IP address, this network, and I want to divide it into 2 networks, okay, I can come here and put an A. I could put a B. So those are going to be my 2 networks. See how easy it is to subnet an IPv6? Remember how much calculations we had to do with IPv4? No, all I have to do, pick 1 digit or 2 or 3, depends on how many networks you want to have, and then choose any numbers you want to go for it. Okay, so let's go back here to the PowerPoint. So that's basically what we mean by the subnet IP address. Basically, a piece of that IP address is going to be taken for the subnet network. Okay, so what else do we have? And of course, the interface for the IP address, which is basically going to be 64 bits. Okay, let's keep going. Oh, now we're going to talk about the link local IP address. The link local IP address usually, and you'll see that, always start with FE80, and then colon, and then you decide whatever you want to put after the colon the number. That's basically going to be for the device itself. As I said, let me just go back here and remind you about the LLA. It's going to be automatically generated by the operating system, by the operating system. And if you don't like whatever the operating system is generating, you can assign it by yourself, and I'm going to show you how to do that later. And link local basically are used for local communication. Global unicast IPv6 is used for remote communication, or the internet, if you will. Now, we're going to talk about how do we configure the devices. Well, I'm going to show you how to configure the devices using IPv6 and IPv4. Just IPv6. And then I will show you how to configure a router, and then I'll show you how to configure a device. So let's go to the packet tracer here. And you know what? I am going to use this IP address here to configure the devices. And remember, let's go to the packet tracer. And here we go. So this is my packet router, and you can see here I got gigabit Ethernet 00, gigabit Ethernet 01. Let's go ahead and configure both of those interfaces. CLI I hope you can see this. No. Okay, so let's see here. Enable, configure terminal, and then interface G00. And now here's what I'm going to do. The first thing we have to do before we do that, let me just exit. I'm going to type IPv6 unicast routing. That basically means, as I said before, by default, those devices will not process IPv6 frames. So if you wanted to do that, you have to actually enable it by typing IPv6 unicast routing. Now after that, this is what you do. You type interface G00. Now here's what we do. We say IPv6 address, and then you type that IP address. I'm going to go here. 2000, and I'm going to use this one I said. So 0DP8. I'm going to write the long version of it. Of course, it's going to make it a lot easier if I just... And then I will go with A. So I'm done with the first part. And then for the second part, I'm just going to assign 1 to it. Remember, I'm just going to highlight this portion here. I cannot highlight. Okay. So the first 4 segments are for the network, and then for the host. And remember, you have to type 64 prefix. Now I'm done with the first part. Now what I'm going to do after that, I'm going to assign a link local IP address to it. So IPv6 address, and then you type F. Now you could go lowercase, uppercase, it doesn't matter. FE80::1. I'm going to use 1 again. You have to type link local. And then after that, no shut down. And now it's up. Now what I'm going to do, I'm going to exit. I'm going to check the other network IP address, interface G01. And then I'm going to use the same IP address, but again, I'm going to change this one to be B instead of A. I'm going to go with 1 again. That's the global unicast. And then after that, I will use the same link local. Remember here, this is very important. Why am I using the same link local for both of those interfaces? Well, let me just type no shutdown here. And then it's up. Let me close this. The reason why I'm doing this, because again, remember, this is a network and this is a network. So I can use the same link local IP addresses for both ends for this router, because again, they're not going to try to be communicating together using link local. They're going to be using the unicast global. So I am done assigning IP addresses here. Now let me just go to this computer in my system. Now you can see it's green already. Well, I haven't configured this device yet. Why is it green? Well, let me show you why it's green. Look what do I have here. Automatically generated a link local address for this computer. And then if I go here, automatically generated a link local. Oh dear God, my mouse is acting weird. A link local IP address for this device. Now, of course, if I don't like this link local IP address, I can come here and change that to be, for example, 10. That will work. And I can come here and do the same thing here, 10. Now remember, think about link local IP address as a private IP addresses. As long as you are local, you can use them, but you cannot use them outside of your network. Okay, so that will be number 1. Number 2, let's go ahead and assign an IP address, global IP address. In this case, I will put 2000. Let's go with 8. Is it D? Let me just go back and check. It's DB8. DB8. And then I'll put a 0 here, and I'll put A. Same network. Colon, and this time I'm going to put 10. Previously it was 1 for the default gateway, and then you put 64 here. And now you have to tell me, what is a default gateway? Well, you really don't, because the default gateway that's going to be used for this machine is basically the link local of this interface. So this interface here has a link local IP address that's going to be used for the default gateway for that computer. But if you want to change it, just go ahead and copy this and put the default gateway, the unicast global. But again, it's not recommended. Just go with the default gateway. which is the FE080::1 that I assigned there. I can do the same thing here. And let's go ahead, 200DB80. We said B, this is going to be the network, and then here I'm going to put 10, and now here I'm going to put 64. Now I save it. Now I think I should be able to ping between those devices. So let's just go ahead here and go to the command. So ping 200DB8. I hope I didn't make any mistakes. B, column 10. It's okay to lose the first one, but I hope we'll not lose the rest of them. Let's see here. It looks like we're going to lose the rest of them. Yep. Let me see the routing table, or maybe I made a mistake actually with the IP addresses. Maybe I have to put the prefix. Nope, there's no need for that prefix. Let's see here. If I go here and exit, show IPv6 route. Well, here it is. This is A, this is B, this is link local. Yeah, I can't see anything wrong with it. I'll try to figure that out in a sec. Let me try to ping the default gateway. Oh, sorry. Well, I wasn't able to get to that part as well. Let's say ipconfig all. Look at this. There is no IPv4, of course, but here it is. Physical address. This is link local IP address. Is there any default gateway? Oh, look at this. He's complaining there's no default gateway. So let's go ahead and do that. Maybe that was the reason. I'm going to copy this, Control C, and put 1 here. Let's do the same thing here. Yep, exactly. That's the problem. You need to have the default gateway. What was I thinking? Let's try again. Now, this is just going to show you the default gateway for IPv6, but it's not going to show you the IPv4. Let's try and see if I can ping 10 again. Oh, look at this. Automatically worked. No problem. Okay, so we got this part covered. Now I was able to get all these devices configured automatically. Oh, so not automatically, statistically. I actually came here and assigned those IP addresses by myself. Okay. I hope everything is going smooth with you so far, so you don't have any problems or difficulties. So let's keep going here. Link local, we talked about that. And now we're going to talk about something. I consider this is the little bit complicated part of this, which is basically not that complicated, but you need to understand how does it work. So, first of all, we're going to talk about, again, just remember, this is a very simple case, 2 computers and 1 router. Imagine you have hundreds of these routers and hundreds of these computers. Are you going to manually do it by yourself? No, you're not going to do that because, again, it takes a long time, and the human error section could be a big deal here. So you want to make sure that no errors are going to happen or no mistakes are going to happen. So what we usually do, we dynamically assign IP address to those devices. So how is that possible? How is that working? Well, there's a mechanism that you need to understand. And this part, again, I'm going to be talking a lot. Try to organize your thoughts and work with me here. Number 1, we are going to use what we call Internet Control Message Protocol version 6 to get this job done. How? Well, basically, we have two types of those IPv6 messages. The first one's called RS message and the other one's called RA message. RS message basically is the message that your device, your computer, is going to be generating. Now you're connected to the internet and you want to have a global unicast address. Because again, the link local is okay to be communicating within the network, but I don't need that. I need the other IP address, the global one. So your computer basically is going to generate this RS message asking, is there anyone that can provide me with IPv6 addressing and information? And specifically, I'm asking for routers to do that. Now, the router, on the other hand, will receive your message and is going to respond with a message called RA message. This RA message basically will tell you everything you need to get a global unicast address. So again, we are not talking about link local here, we're talking about the GUA. Your device is going to shout out to everyone, is there any router in this network that can give me information? And then if there is a router, that router is going to tell you, I am here, and I'm going to provide you with the information that you need. The information basically you're going to get is basically the network prefix and the length prefix, that's 64-bit that I was talking about. The default gateway, how do I get connected to the router? And the DNS and the domain name. So you basically need those type of information. Now, when the RA message is going to be produced, you're basically going to be, there are three scenarios basically that the RA will be able to help you get the information that you need. We have the SLAAC, and then we have the SLAAC with a stateless DHCP server, and we have stateful DHCP server. Now, stateless auto address auto configuration. Yes, that's the SLAAC. So what's the difference between all these three? Remember, your device produced an RS message asking for information from routers. The router is going to respond with an RA message. This RA message basically is going to tell you how do you get those information. Now, there are three types of or methods that the RA can actually provide you with the information that you're looking for. The SLAAC, the SLAAC with a stateless DHCP server, and then a stateful DHCP service. And again, if I want to summarize those three, basically, SLAAC means the router will give you everything you need. SLAAC with a stateless DHCP server basically means if there's a server and there's a router, both of them are going to work together to give you the information that you need. Stateful DHCP v6 basically means you will get all the information from the server. So there are three possibilities. You get all the information from a router, all the information from a server, or the server and the router will work together to give you all the information that you need. This is, again, very important to understand. So the RA is going to specify what method you're going to be using to get the information to build your IP address, your GUA IP address. Remember, router will provide you using SLAAC. Router and server will provide you using SLAAC with a stateless DHCP v6. Or the server will only give you all the information that you need without the help of the router, and that's basically what we call stateful DHCP v6. Now, how do they work? Well, let's go ahead and take one by one. The first thing here is the LCLAC. As I said, as you can see here, you will be giving this portion here, the prefix, and the length of the prefix. Very important. Those are the information you're going to get from the server. Sorry, from the router, not the server, just the router. Now, after you get this portion, you don't have this portion. This portion is not going to be given to you, the interface ID. And this is basically where the magic is going to start. Your device is basically going to generate this portion. How is this going to happen? Well, basically we have two methods. We're going to use what we call an EUI64 or we're going to use what we call a random generation method. Now, I'm going to talk about them later with a lot of more details, but just to give you an idea, this portion is going to be basically replaced with your MAC address. And we know that MAC addresses are unique, so I don't have to worry about the uniqueness of this part of the IP address. So the router will give you the prefix and the length, the prefix length, and then your device is going to use the MAC address to generate this portion, or randomly just generate a number. Now, if you go with randomly, you will have a problem because, again, even though the possibility for having two devices to randomly generate the same number of 64 bits, which basically, again, it's all about possibilities, probabilities, but again, the chances for two devices to generate that exact same number is very, very limited. But again, it's a possibility. And because it's a possibility, your device needs to actually send a message to all the other devices telling them, this is my interface ID. If anyone else here is using the same interface ID, he should speak now or just shut up forever. And that's how it works. Well, again, we're going to talk about those two techniques later. But just remember, the router basically will provide you with those 64 bits number and the prefix number here. Your device is basically going to have a responsibility to generate the interface ID, which basically could be happening using this part, which basically means using the MAC address, or randomly generating that part. And this is CLOAC. Now, when you use the CLOAC with the stateless DHC IPv6, basically the same thing is going to be repeated, just like in the CLOAC. But again, another thing is going to be added here, which basically is the link local information is going to be provided to you using the router, and as a default gateway, and all the information is going to be provided to you by the router. And in addition to that, your computer will need to know what is the DNS server IP address and what is the domain name. Those information is basically going to be provided to you by the server. So the server is going to provide you with the DNS server, domain name, and the router is going to provide you with everything else. But again, remember, it's going to provide you with an IP address that contains only the prefix and the prefix links, and your computer need to generate the interface ID. Now, the third one, which basically when you have a stateful DHC IPv6, well, this part, you will get the whole length of the IP address. So the IP address is going to be generated by the server, is going to give it to you. You don't have to use your MAC address or to randomly generate the interface ID. No, a full IPv6 is going to be assigned to you. So your computer doesn't need to do anything. A DNS, the default gateway, the domain name, and other information is going to be provided by the server. The router still works here, and the router basically is going to have a responsibility of telling you what is a default gateway and what is the link local IP address. So those are the three types. Again, it's extremely important to understand the difference between them. And if you're planning to take networking too, you will have a whole chapter just to cover those three slices in the future. Okay, so let's talk about the process of creating the interface ID. As I said, randomly generated or using the EUI64 process. Well, randomly generated, as I said, randomly generated number. And then after that, your computer is going to generate what we call a DAD, duplicate address detection protocol or message, to try to detect if anybody's using that IP address or not. But again, if your device is going to go ahead with the EUI, well, this is how it works, and I want you to pay attention to those numbers here. Number one, we know that the length of half of the IPv6 is 64, and this is the MAC address, which is 48. So you can see here we have a difference with a number of bits here. 48 need to fit for 64. So what are we going to do? And I want you to pay attention to this. This is my MAC address. I'm going to divide the MAC address into two parts. This is part number one. Sorry, not 75. Let me just start from here. Oops. No. Here. This is part number. Why is it? Yeah, here it is. This is part number one, and this is part number two. And as you can see here, this is part number one, and this is part number two. In between them, we're going to be adding 16 bits. So the total is going to be what? 64. And those 16 bits basically are going to be all ones except the last bit is going to be 0. So 16 bits of all ones except the last one is 0. Now if you convert that into hexadecimal, you're going to get FF and then colon FE. So that will be the first step. In the middle, between, you divide your MAC address into 2 halves. And the one in the middle here, you're usually going to have to add FF. We'll just do that, and I'm going to remove it. FF, and then FE. And as I said, this FF is basically 8 ones, and this FE is 7 ones, and then 1 0. Okay, so that would be the first thing. Second thing is, you come here to this digit here, and whatever it is, you just add 1 to it. So you can see here, A, B, C, D, E. Well, actually, not 1. Should be explained here somewhere. You have to flip. Yep, here it is. The 7th bit. So I want you to look at this C and this E here that I'm highlighting. C by itself is, what is C? A is 10, B is 11, and C is 12. So 12 in hexadecimal, let's see if you can let me write it here. 12 is basically 8 plus 4, right? So 1100. Okay, so what he's talking about here, this is the bit, and again, remember, this is F. So F is basically 1111. Remember, this part is F, which is basically this F here that I highlighted, and the other 4 bits is the C that I highlighted here. So altogether here, if you calculate, those are going to be 8. He wants you to come to this bit, the 7th one, and flip it to be 1. And if you do that, you will get E instead of C. I don't know if you're going to be asked about that or not, but I heard recently that they're not doing this anymore, and they're just going with the random generated number, which I think it's stupid, because why do I have to generate a broadcast message to make sure that nobody's going to actually have a duplicated IP address? But again, I heard that that's what they're going for these days. Okay, so here we go. This is basically how it works. And if you go to your device, and if you don't configure your device manually, and it's going to be happening automatically, you can basically see if it's going to be using a random device or it's going to be using the MAC address. How do I know that? Well, let me just show you how is that possible. We're almost done, by the way. Let me just continue here, then I'm just going to show you how can you tell which methods your computer is using. For the LLA, as I said before, your computer basically going to receive the LLA from the router, and the same thing is going to be applied here for the prefix section. Again, with LLA, I usually change it. I recommend everybody to change it and not just depend on that address going to be generated by the computer, because that address is very, very long. So we are always looking for something very, very short. Okay, so actually there is nothing here really, really important. I'm going to go ahead and show you how do I auto-configure my device and how do I know which method is used by going to the packet tracer. Now look what I'm going to do. If I go to this machine, let me take this out. Take this out. Take this out. Take this out. And I'll keep this 10 here. Well, you know what? Let me take this out as well. Now, look what I do. If I click on DHCP, basically nothing is going to happen. Why? Well, basically because my computer here is not connected to any server. But if I click on Auto Configure, this is basically where the router is going to shine. And look what happened. Automatically, the router sent me information. And this, look at the only information that the router sent me here. Very similar to the one that I had. Basically, because I automatically signed it, so it's basically inside the router somehow. So the router decided to send me the same information. What I'm going to do, just to change it a little bit, I'm going to delete this device. Oh, you know what? Yeah, I'm going to delete this device. And by the way, I'm using a really, really old version of Packet Tracer here, so whatever you have should be a little bit different. Let's see if that's going to work. Well, I wish I thought about this before I automatically assign an IP address to it, but let's go back here to this machine. Desktop configuration. Okay, as you can see here, this is automatically generated. Click on auto, and here we go. Look at the IP address. I got 2 DPA, and look at this number here. This is basically the IP address that is generated. Look at this here, FFEFE. So that tells me that this is using my MAC address. And this is basically, again, the same thing, FFFE. You see this, FFFE? That basically indicates that I'm using the MAC address to generate those parts. Of course, if you don't like them, you can change them. You go auto static and then do whatever you want. But again, we'll just keep it that way. Let me close this. And remember, I got 290.21 and then 7C and then B1 and BC. Let's see what is the MAC address that I have in this machine. So we'll just type ipconfig. Well, it's not showing me everything. Let's go put all. And here is the MAC address. 009021C7. Yep, it is. And just remember those 3 bits, which those 2 hexadecimal numbers 00 are usually 8 zeros, and they just change the last one, the 7th one, to be 1. So that's why I have 2. Let me just go back and check. I'm pretty sure it should be 2. Yes, 290. Here it is. Okay. Let's go back here, and that's basically how I know about the MAC address. We stopped at the multicast types. We have basically 2 types of multicast, a well-known multicast and solicited node multicast. The well-known multicast basically are 2 groups. The first one is FF02::1. You should remember those numbers, by the way. And FF02::2. $:1 is for the computer devices, the host, and then ::2 is for routers used. The solicited node is basically very similar to the the FF02::11, but you're just going to have to specify that by yourself. Subnetting IPv6, as I said before, we're going to cut part of the 64, and all together is going to be the prefix. Oh yeah, I just remembered. You put them all together as a prefix 64. But you know that portion of that 64 is going to be for the subnet ID. Here, he decided we'd go with 16 bits. You can go with 4, you can go with 8, you can go with 16, you can go with more, you can go with less. It doesn't matter. And the good news, as I said, all you have to care about is when I ask you to subnet an IPv6, and usually they're going to be 2 networks or 3 networks, just go ahead and change the last hexadecimal digit you have in your network from 0 to be A or B or C or D or whatever you want. And that's pretty much it, I believe, and that will be the end of this chapter. I don't even know if you actually need this Word document. It doesn't look like it's helpful anyway, so I'm going to just delete it. There's no need for that. Oh, you know what? I'm going to use it for the other network that I'm going to be working on. Now just remember, I'm done with the PowerPoint, which is a good news. And this thing, there was nothing that you have to worry about, so I'm going to take that away. Now, what I'm going to do, basically I'm going to come up with a scenario to configure the whole network here, and I'm going to provide you with the network itself, with the commands that I'm going to type, and the file and everything later. So for now, I am done, and this will be the end of chapter 12. And as I told you here, if you compare chapter 12 to chapter 11, chapter 11 I had to create 3 videos for it, but chapter 12, 1 video was more than enough. I hope everybody is understanding what I'm saying, and just remember, if you don't understand, send me an email or you can comment on the video if you want, and I'll see you guys later when I'm going to start working on this network here. So have a good day.